now about running DuckLake in Azure, and we will introduce what I have called MPZSQL. We'll see later what is that about. So, summer holidays, I saw these guys swimming. Here is the map where I saw them. It was a very far location, and I thought, well, if those guys can thrive there, why cannot DuckLake thrive in Azure? So, the setup I needed all the components for DuckLake running in Azure, plus more stuff that we will discuss later. So this is how the DuckLake client works. It needs connection to a database, for example, PostgreSQL. In Azure, getting a PostgreSQL, no problem with that. And then also it needs a storage, a blob storage. So could be the typical Azure storage account with the hierarchical option enabled that is also known as a data lake. But we have some news here that I will share later that is not straightforward. And then other things I can use from Azure, I can use Azure Container Apps, and I can you also use Azure VNet. So challenge one, write to Azure Storage. If you check this issue from DuckDB, you see that there is no support yet for natively writing to Azure. But in that same thread, you can read about some really smart guys that have found a way around to it. And it's basically using something called FSSPEC that allows you to mount or register a file system. And then that file system can be used by DuckDB to write to an Azure storage. FSSPEC, so far I understood that is only a Python thingy, so we will be using Python. Challenge two, the compute. So there will be multiple and different clients. As you can see in this picture, each client that need to read or write to DuckLake, it needs connections to the catalog and connections to the storage. Uh, Also, it implies that since it will be running the extension, the DuckLake extension, it needs some compute. Uh, there are many clients that can have this extra space, or you are the one who wrote those clients. For example, if you write a web application and you want it to store data there, that web application will be running, for example, in a container, and then in that container you can install whatever you want, and in this case DuckDB with the DuckLake extension, and then that allows you to write and read there. I call them these near clients, as you can see in the original article. So what I talked about before, near clients, they could be also running, let's say, in Azure, and they have what it says here. They have the compute, they have connectivity to the catalog and to the storage, so no issues. Uh, far clients, let's see if we can find a better name, but for now we call it far clients. So those are clients that, for example, analytic tool, a BI tool, that there is no space for extra compute, that you don't have full control of the application, or it may be hosted somewhere and you cannot, let's say, hey, run this also here. That's not possible. Or it could be that the connectivity to the catalog or to the storage is low, or there is no connectivity because maybe you don't want to expose these things to the public internet, and then maybe the service you want to use cannot provide you a fixed IP or a private endpoint or whatever. So because of this challenge here, I decided to write this query proxy here, and I have called for the time being MPZSQL. Basically, what it does, this has connectivity to the storage, to the DuckLake, I mean to the metadata database, and it also has a port exposed to the outside world. When allowing any application that speaks, in this case, I have implemented JDBC or Arrow DBC connectivity. Why? What is MPZSQL and why I need it? As we talked before, there could be clients that there is no space for the extra compute for the DuckLake extension, that you cannot install it. Could be that in that location there is no connectivity to the catalog or the storage, or it's slow or not stable. So that's why I created this query proxy that I call MPZSQL. What it is a query proxy written in Python that runs on Azure inside the container web. So basically, it's a container image, exposes a JDBC and Arrow interface via TCP/IP. So from any client, you can put the address, a port. So far, I have not put the tested the credential, but it's coming soon. And then this one provides the compute to run the DuckLake extension and has private and fast connectivity to Postgres and Azure storage account. Also interesting is that you can have as many as you want. You can have very tiny ones with very small number of cores and RAM, or you can have very big ones for very heavy loads that could be have a lot of RAM and a lot of cores or CPUs. So the MPS SQL, which are the components, well, the Python code, and then I have created some GitHub actions, test that they are still at low coverage of 36%. Many are failing, but still working on that. And then there is another GitHub action that deployed the Azure infrastructure, the infrastructure as code, and that's written in Bicep. Let's go and see the demo. Okay, here I have my container app. I will click start now. Did it click? Yes, now it's starting, and I will go here to see revisions and replicas. All right. So here we can see that my application has started to run. Here we can see that it's trying to get ticket to authenticate to the container. Then we are seeing that installing some extensions, that it's trying to connect to the Postgre and stuff. And now we can see that it's running DuckDB, and this is the address that is being advertised. Then the Postgre stuff, which database it has connected. And now, okay, now I go to a JDBC client, in this case, DBWeaver. I click, let me put this on this side. I think it will look better so we can see the logs updating. So I can here click connect. And now we saw that there were some activity here happening the moment I connect, and the moment I click here expand, we saw that there was more things getting all the get DB schemas and get tables and stuff. So I have this my DuckLake database, and here I have a schema called main, and here I have a table called T1, and this T1 has two uh, columns, ID and name. So if I come here and click this, we can see that there is a lot of things happening here. But basically what it happened is that it just accessed the, well, it received this command, then it accessed the catalog in the Postgre, and then it got access to the storage, and then we got the result of the query here. Okay, now I have here the storage account and the container where I have the files. You can see all these are uh, Parquet files, very small ones because I'm inserting one by one. Okay, here I can see. And if I come here now and put 11 demo, I'm doing an insert here, and I execute this one. Says that okay, it added one row, and if I refresh here in the container, we can see that there is this new file here, 722, 722, that was created because I just inserted. And of course, if I run the select here, um, you can see that the new record I inserted is there. So this is, in a nutshell, the DuckLake fully running in Azure with some challenge that I have to do and stuff. Um, if you think this is interesting and you want this to be released as a open source thing, just let me know. As I said, I have still to do some work to clean the repository and then do all the tests and all that stuff. But I think this is something interesting and especially useful. Of course, I don't know what is the future when these challenges that, for example, MotherDuck doesn't support yet Azure storage for DuckLake will be gone, and then maybe this doesn't make sense. So there are many variables, but I think it's interesting first to understand how this really works, and then maybe it's also useful in the future. Thanks for watching.